Good afternoon. Uh, let's start our lecture on fundamentals of electronic. It will be our lecture 4. Course code is CSB 1214. For today's class, we'll be trying to complete Unit 11, Unit 12 from Block 3 and from Block 4, Unit 13. Our objective for this class and what will be the outcomes of the class will be understanding the structure and operation of B.Tech and FET, analyze transistor characteristic and mode of operation, differentiate between B.Tech and FET devices, explain and design basic amplifier circuit, understand operational amplifier concept and ideal behavior, apply knowledge in real world electronics applicant, and develop problem solving skill in analog electronics. So moving forward, let's understand the structure of B.Tech. There are three reasons for this structure. Here you have seen three regions of B.Tech: emitter, base and collector. It is divided into P, N, P, N. Okay. So emitter is heavily doped, base is very thin and lightly doped, collector is moderately doped. So junction, here you see emitter base junction, that is forward bias this side, and collector base junction is this side, C, which is written C, and E for emitter base junction, that is forward bias, collector base junction, reverse bias. Okay. Next, B.Tech working principle. What are the working? How it works is small base current controls large collector current. Okay, small base current controls large base collector current. So current relations here, it will be I suffix E equal to IB plus IC. This will be the current relation between emitter, collector and base. See, base, emitter equal to base plus collector. Huh? So mode of operation will be active mode, cutoff mode and saturation mode. There are three types of mode. What are the mode of operation? There are amplification, which is also known as active mode. Cutoff mode is off state and saturation mode is on state. Moving forward, let's us know about the B.Tech characteristic and application. So what are the characteristics of B.Tech? Is input characteristic I, B, Vs, V, Be. Okay. Output characteristic is IC, that is collector, no, Vs and Vce. So this is the formulations of the characteristic of B.Tech, input and output characteristic. Reason, there will be cutoff, active and saturation. Earlier we have discussed this one, mode of operation, that is also known as reason, which is cutoff, active and saturation. Amplification of B.Tech. Amplification of B.Tech. What are the application of B.Tech? Amplifier, switching circuit and oscillator, digital logic circuit. These are the application basically used for B.Tech. Now B.Tech operation and PN example. Okay, like we have seen in this diagram, N, PN, emitter, N, P, N, N. I think we have not discussed this one. Bipolar, actually B.Tech means bipolar junction transistor. Bipolar junction transistor, remember that. A bipolar, what is BJT now? A bipolar junction transistor, that is, it's a three-layer semiconductor device. Three-layer semiconductor device types NPN transistor and PNP transistor, and terminal emitter base, emitter for E, emits charge carrier, base is thin control region, collector stands for C, collect carrier. So called bipolar because both electrons and hole particles, because it consists of both electrons and holes particles. So here BJT operation NPN example, electron flows from emitter base, then flows to base, then flows to collector. So base control flow, small IB tends to large IC, means IB means base electrons from base to large IC. So current gain here is beta equal to IC by, means I electron collector by electron base. So example, if IB equal to 20 mu A, that is beta equal to 100, then what will be the value? IC will be, beta is given and IB is given. So we'll cross multiply, right? How it will be. So IC will come in front, beta will go. So 20 divided by 100. No, 100 divided by 20. So it will be so 2 M empire it will be. Next, unit 12. Moving forward to our unit 12. Field effect transistor, which is FET FET, FET FET, field effect transistors. A voltage controlled, it is a voltage control device, high input impedance, it has high input impedance. And what are the types of FET? JFET, this is junction FET, field effect transistor, and MOSFET. MOSFET is metal oxide semiconductor FET. So structure of FET. So terminal, there are three sections. Gate for G, source is S, and drain is D. Current flows from drain to source. So current will flow from D to source, means S, D to S. So this is the difference between JFET and MOSFET. In this diagram, you can see what is different. In JFET transistor, what happens? Z have only one input, right? But here you see S is input. In MOSFET is different. The diagram in JFET junction, FET means G will be the junction. So from junction it will have the input. MOSFET is metal oxide semiconductor. So what it happens? It will take input from the source. See here again, types of FET, JFET. It's N channel, it has N channel and P channel, okay? And MOSFET, enhancement type is there and depletion type is there. In JFET, N channel and P channel, MOSFET, enhancement type, and depletion type. Working principle of the field effect transistor is controlled by electric field, gate voltage, control channel conductivity, no gate current. This is ideal case. Characteristic of FET again, drain characteristic and transfer characteristic. There are two types, drain characteristic and transfer characteristic. See the difference? In drain characteristic, it will be ID, Vs and VDS. Okay, transfer ID, and at last you see Vs, VGS. It will be GS, transfer, no? Gate. That is called gate. G is called gate. D is drain and S is source. Next, advantage of FET. Advantage of FET. What are the advantages of FET? High input impedance is there, low noise, low power consumption, and better thermal stability. And application, amplifier. It is used in which application? Amplifier, voltage control resistors, digital circuit like MOSFET is IC, and switching device. Now let us know the example of field effect transistor can be MOSFET. Again, it's an example and it can be type. Means here example is MOSFET used in microprocessor and memory chip. See what is MOSFET now? MOSFET is metal oxide semiconductor field effect transistor. Is the voltage controlled semiconductor device used to switch or amplify signal in electronic system, right? So here you can see the diagram. You see source, gate and drain is there. Gate is metal gate, that is N-type, P-type and N-type, na? Gate oxide and bulk. And same in second picture also, the same picture. What it does, it acts as a gate control switch using a small voltage on its gate terminal to control, turn on or turn off a larger current flowing between the source and drain terminal, like a fuse wire, which we use as a fuse wire. Moving forward, you can see in unit 13 amplifier and operational amplifier. The difference we'll see here. Introduction to amplifier. What is it? Amplifier increases signal strength. That is input. What it inputs? Weak signal to input is weak signal. Okay. Then output, what it becomes? Strong signal. So it increases signal strength. Basic principle uses an external power source. Uses an external power source. Basic principle is uses an external power source, maintains signal shape. Key parameter is gain, bandwidth and efficiency. Gain, bandwidth and efficiency. Type of amplifier, there are two types. One is based on signal, another one is based on configuration. Under this base of signal, voltage amplifier is there, current amplifier is there and power amplifier. And based on configuration, common emitter, common base and common collector is there. Next, application of amplifier is used in audio system, communication system, medical instrument, radio and video, TV broadcasting. Okay, it is used in this platform of application. Operational amplifier, it can also be written as OP-AMP. So operational amplifier is a high gain electronic amplifier. Symbol, two input is there, inverting that is negative and non-inverting that is positive, and only have one output. Two input will be there but only one output. Two input will be inverting and non-inverting. Inverting is negative and non-inverting is positive. Next, ideal operational amplifier characteristic. It has infinite gain, infinite input impedance, zero output impedance, infinite bandwidth, zero offset voltage. Then we can say it is ideal operational amplifier characteristic. So operational amplifier parameters can be gain, input resistance, output resistance, bandwidth, slew rate, and basic operational amplifier circuit will be inverting amplifier, non-inverting amplifier, voltage follower, and summing amplifier. Example, if gain equal to 100 and input equal to 0.01 voltage, then output will be 1B. These are the basic difference between bipolar transistor versus MOSFET versus IGBT. So here we'll know the basic difference. In bipolar transistor, you see base, emitter, and collector. Base is what? It can be G. See, operation speed can be slow, drive power high, large current capacity excellent. Okay, this is NP, NPN, and this is PNP. This is how the diagram look in P-type. Bipolar transistor. Okay, mainly used for low power application because it uses current drive now, and which has high drive lows and make using high frequencies more difficult. MOSFET is, you see, MOSFET, how's the example? Source, gate and drain. But in bipolar, what happened? Emitter, base and collector. So operation speed is fast in MOSFET, drive power is low, and large current capacity, that is 4. Uses voltage drive which has low drive loss and is well suited to using higher frequencies. This is for next will be IGBT, that is emitter, gate and collector. This is almost similar to MOSFET. See, only the arrow symbol is different. It's coming to emitter in IGBT. Operation speed slow, drive power low, large current capacity excellent. Okay. Combines the benefit of both transistor and MOSFET, the leading device for high power application, higher frequency use is an issue here. Next, these are the self-assessment questions for you to practice at home and solve by yourself. And if any query or doubt while solving this, please go through your SLM for your reference and practice. And if any queries while solving or not able to understand the syllabus and content from the slide, you can always reach out in this given email ID. Thank you. See you in the next class next week.